Hello everyone, welcome back. And this video is the last video of the series from the single dimension perspective. What we are going to do in this video, let me just spin up the one which I'm using the last one. Yeah. So we have already seen the introduction or the explanation of the two major function, calculate k cluster, and then by now you can understand why I'm using the recalculate centroid, because clustering depends upon the centroid, and in order to calculate the centroid, in order to calculate the right cluster, we need the right centroid, and that's where we are keep running the algorithm till we have the clean clusters coming out based on our points, right? So now we are going to run the end-to-end solution, and I'm actually gonna show you the simulation so you can see how these centroids are moving and how it's gonna converge at the end, right? So the data set you have already seen. So let me just jump into the data set. And by the way, this notebook has been uploaded on the Git. You can download it if you want to, and you can customize the function based on your own understanding. Let me just increase the point from 10 to 20, and then let me just show you the random points. So we have, you can see one dimensional array with 20 points. And now I'm going to call it, I'm just running 5 iteration, right? You have already understand that data set containing the points, and then we are asking for the number of clusters. So in this instance, we are asking for 3 cluster, and we are running it for 5 iteration, and we will see whether 5 iteration is enough to converge or to reach to the local minima or not, right? So it's more like a hit and trial method, especially in the real life, that you need to find that number. It really depends upon the problem, but and the data set. So let me start with 5 and we'll see. So I'm printing all that log as part of my function just to show you. So in each iteration, and that's where I have explained how the algorithm is working in my first video. If you haven't watched it, please watch it before this one. That will help you to understand how this log is coming and what I'm actually doing to tag cluster 3, cluster 1, and cluster 2 to each point. All right, so you're going to see that with each iteration, the centroids are changing. So these are the first centroid that I picked just randomly, and then in the second iteration you can see the cluster has been changed from cluster 3 to cluster 1, because the center point of these 3 cluster they have been recalculated as part of the recalculated centroid function, and then we are again shuffling the point based on the new centroid, right? And then you can see the first point stick to cluster 1 all the way, I believe, till the last iteration. One thing which I want to show you, remember I told you there is going to be a conversion point. So let me show you. So after first iteration, my centroid or the center point are different. So you can see these are my first centroid, which I picked randomly. But once I recalculate, you can see the new centroids are coming 67.399 and 28. That was for the reshuffling of the once we generate the first cluster, and then we recalculate the center point, which is obviously the mean of those points. Then we are recalculating or reevaluating the points, whether which point is closer to which cluster. So after the first iteration, in the second iteration, I realized that my 72, which is the first point, is closer to the first centroid compared to the other two. So that's the most important one, and that's where I actually did the implementation just to show you, because in the unsupervised learning we don't have any training example, right? So we need to be mindful of this complexity. That's why if you have your own implementation beside the built-in implementation that you normally use in your day-to-day problem, that manual implementation will really help you to investigate for outliers or for those cases which you believe come under cluster 1, but they are coming under cluster 2. These sort of investigations will really be done through the manual implementation. And now I can see the full internal mechanics, that how my point is moving away from wrong cluster to the right cluster. So that 72 point, which is my first point, it is closer to the first mean, or first center point. So that's why I'm tagging it as cluster 1. And then you're gonna see in the third iteration, we're still changing, but the center point. But did you realize that we already have our first center point is converged, like it is not changing anymore, right? However, the second center point and the third center point is still changing, because we are still moving the point in our space. Now, let's go toward the fourth one. In the fourth one, you can see the second center point is not changing, and the third center point is also not changing, which is interesting. That means we are reaching either to the local minima, or there may be no changes in the point based on the new mean. And our last iteration is confirming that, okay, we reached to the local minima, because there is no changing in the center point. Obviously, this is the simplest form of the algorithm, where we only have one-dimensional data. We are not using multiple feature or multi-dimensional data. But now you can understand, in order to reach to the conversion point, we need to run the iteration, and that's the indicator. In the last 3 iterations you have seen, the whole system converged to a point where there is no changing in the cluster shape. So that means that's the best clustering we are getting. Now, the same thing if I want to represent from my diagram. So yeah, let me show you the coloring scheme, so you can easily understand. So initially I'm plotting my data point with blue, and my first iteration, which is which is completely on random basis. I'm just picking random indexes and considering that these are my centroid, right? So I'm representing them with green. Now, if I come back in here, so you can see these are the blue, and my first green are this. There's only one thing I need to change. Bear with me. What I can do, yeah, the first 3, I can do it like this with gray. And let me just go back, run my data set, and show you again. All good. So now you can see the gray is not displaying. Why the gray is not displaying? Why I'm getting all blue points? Just so these are the black points. I changed it in the other file. I made those changes in the other file. So let me see. Yeah, black, red, green, blue, brown, yellow. And let me see if I want to change gray to more visible. How about which color? I'm just stuck with the color. Let's see whether it works or not. Gold. So let me come back again. Let me regenerate the point, print the data set, and let me show you yeah. So the gold is, you can see the gold is just, under the yellowish color. But anyway, that's enough for us. One more time, I'm just going to be bit annoying in here. Let me just blue, and what we can do, red, green, and then we have brown. Yeah, I think that's better. And the last one I'm going to do, let's use pink. I think that should be all right. Yeah. All right, so now you can see the blue points are gone, because for somehow I'm unable to see those blue points. Maybe because they were overwritten by other points, right? Or maybe the size of the point is big. But then you can see We don't have the red because I believe red has been overwritten again. So let's look at the data first, right? So we do have, and the second thing, we are looking at the one dimension. So don't worry about the point allocation because just the one dimensional data. In the next video, we're gonna see the multi-dimensional data, which will really help you to see the actual clustering and how the thing has been changed based on the clustering. All right, so let's see if we can map it. So our first cluster, which is random, is 64, 10, 70. These are the centroid, and then obviously we are changing it. And let me see when it has been converted. So after 73, the first one is convert, the second one, oh, in the second round, so you can, that's why we are unable to see more color. But there is a reason because in the second iteration, we are converged to our local minima because that is completely random. So the points, whatever we are generating from the random function, it really depends upon the points location on the graph and how these centroids are coming. It happened that look how efficient it is that in the second iteration, it converts to the local minima. And maybe in the some algorithm in some run, we see that it might not even converge to local minima in 5 iteration with even 20 points, right? So it's completely random basis. So now we can see obviously our last you can see iteration is where we are putting the color of pink. So that is actually overriding the previous color, which is obviously blue and red and brown, which are part of the iteration, right? So that's how we can see the changing of cluster, sorry, changing of centroid, and how the points are getting its color based on the nearest point. So hopefully that makes sense. In the next one video, what we're gonna do, first we're gonna introduce the Euclidean distance. Secondly, we're gonna actually change the color of our points based on the nearest centroid. So you're gonna see the formation of the clustering by yourself, that how it's gonna change from one color to another, right? So hopefully that video will make sense. That was the last video where we run it end to end. We see the graph, and now we can easily understand, we can see the formation of clustering. And even you don't understand this diagram because that's not quite pretty, but you can see the movement of point in this log that I'm generating as part of my algorithm, right? So try it and use it. Hopefully it will help you sometime in your actual problems. And if you have any question, please put in the comments. More than happy to answer. Otherwise, like the video, and I'm gonna see you in the next one. Thanks for watching.